We're going to look at some problems for our academic Super Bowl math competition. Kind of just go in order from what's on the outline. So to start out with, if you want to look at this problem, is on the distance formula. So what we're doing, we're trying to find the distance between these 2 points. This is not just going straight across or straight up and down, so we're going to have to do this a little different than just counting the squares. So one thing we talked about doing is we can form this into a right triangle, and then we can count how many squares there are on each of the 2 straight sides, and then we're going to try to find this other side. And what this involved was what's called the Pythagorean theorem, which says a squared plus b squared equals c squared. The c is the hypotenuse, it's the longest side in the triangle, and if you're doing a problem like this, finding the distance between 2 points pretty much should be that the hypotenuse is what we're trying to find. So the 2 sides or legs that we know are 2 and 3. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. And then 4 plus 9 is 13. So that's equal to c squared. We want to figure out what c is equal to, so in order to get rid of that square, we need to take the square root. Technically, doing the square root, we should put plus or minus in front of that, but we know the distance can't be negative, so square root of 13 would be the answer for that problem. And again, the hypotenuse is the longest side of the triangle, so you could check out square root of 13 on your calculator and it should be longer than 3. Midpoint formula, we're trying to find the midpoint between 2 coordinates, so finding the point that's halfway between 2 coordinates. One thing you could do is to graph the points and try to guess where that midpoint is. Another way of doing this would be to just work it out by hand. To find the midpoint, basically we're averaging our x values and averaging our y values. So the x values here are 3 and 4. We'll just average those, so add and divide by 2. And then same thing with the y values. We'll add them and divide by 2. So if you work that out, it should be 3.5, negative 3.5, or they might have it as 7 halves, negative 7 halves. And we could actually graph these and see what that looks like. So if we graph these original points, we have 3, negative 2, and 4, negative 5. And then we're saying the midpoint is at 3.5, negative 3.5. Okay, so I didn't do it, but what we could do is we could have drawn a line in between those. And then what should happen is our midpoint should be right on that line, and it should look about halfway in between those 2 points. The next thing we're looking at is parallel and perpendicular lines. So let's first look at parallel lines. If lines are parallel, that means they have the same slope as each other. And in an equation, a linear equation, we can, if we get the y by itself, we can write it in this slope-intercept form, where the m is the slope. Okay, so what should happen if the lines are parallel, if we solve the equation for y, then the number next to x, that coefficient, should be the same. So this first line was already solved for y, so that has a slope of 3. If you look at our options, there's only one of them actually solved for y. This last one has a slope of 1/3, so that's not going to be it. Those slopes are different. And notice the y's don't have any numbers in front of them, so I mean, we could simply add 5x on both sides on this first equation. that would have a slope of 5, so that's not going to be the same. This second one, we could subtract 2x. That's not going to work. That would be a slope of -2. So hopefully it's this one, choice C, and that would be 3x plus 8, and that also has a slope of 3. So C would be the choice that would work. That would be parallel. Okay, again, the slopes are the same if the lines are parallel. This problem, we are trying to figure out which line is perpendicular to this other line. For perpendicular lines, the slopes are opposite reciprocals or negative reciprocals of each other. So this first one, we would first need to solve for y. You could subtract 2 here as well, but the main thing is the x part. So this slope is 1/2. So we want our other slope to be the opposite reciprocal of that. So reciprocal of that would be 2/1. Opposite of that would be a -2. We want the slope to be -2. And if you look at these answer choices, they are all already solved for y. So we're just looking for which one has a slope of -2. Since it's already solved for y, I can easily see that would be choice D. Next thing we're going to look at is intercepts. So if we're looking at an equation, they can ask what the x-intercept and the y-intercept are. They could ask what the equation is. And those are just where the graph crosses those axes. So on this problem, we're trying to find a line with an x-intercept of 3. So that would be going through the point 3, 0. And a y-intercept of -6. So that would be going through the point 0, -6. Okay, so this would be our line. One thing you could do quickly would be to graph the line and then notice that that line has a positive slope. So if we have y equals mx plus b, if we had the equation, none of these are solved for y, but if you could think about solving them for y, trying to get the y by itself. And I just noticed I had a mistake on this problem, so I go fix that real quick. We're going to change all these 3's to 2's. Okay, so if we look at this first equation, if we would try and get the y by itself, we could add 2x on both sides and subtract 6. So that would be y equals 2x minus 6. So the number next to x, that coefficient, is our slope. So that has a slope of 2. So it's a positive slope anyway. On the second one, we'd be subtracting 2x. So our slope actually would be -2 for that one. So this does not have a negative slope, so that doesn't work. And so D would be the same thing. C would be the same idea as A. We would add 2x and add 6. Okay, and then the good thing about solving it for y is that this constant, if we have it solved for y, this constant, this plain number at the end, is our y-intercept. So on A, that has a y-intercept of 6. B, I don't know if I said that right, y-intercept of -6. And then on choice C, it has a y-intercept of 6. So -6 is what we want. So that's really the only option that could work. What you could do otherwise, you could split things up and have people try these points. So you could try 3, 0 in this equation. So put a 3 in for x, put a 0 in for y, and see if that works or not. Okay, so that works. And then you could try it also for 0, -6. So put a 0 in for x and put a -6 in for y. Would have been better probably to write the equation right there. Would be easier to keep track of what I'm doing. Sorry about that. Okay, so that works as well. But again, you could just graph it to start and, you know, just narrow it down by what kind of slope you have if you've got time to do that. Or one person could find the slope and then other people could start working the problems and narrowing it down further from that. The next thing listed is geometric figures, area and diagonals. There's a reference on your Google Doc that I shared that has some information with diagonals and things. Probably not going to give you just a easy, straightforward question, but I guess it's possible. Here was similar to one of their sample questions they gave. So if a circle has a radius with endpoints at 3, 7, and -2, -3, find the area of the circle. And of course, this would be multiple choice, but what you could do for this, you could just kind of quickly sketch this out, would be one option. And then the radius would be the distance between those 2 points. We could create this into a right triangle. And kind of what we're doing, just look at your x values. We're going from -2 over to 3. So that's a difference of 5 units. The y values we're going from -3 up to 7. So just think -3 to 0 would be 3, 0 to 7 would be 7, and so that's 10 units altogether. Okay, and then we can use the Pythagorean theorem. So a squared plus b squared equals c squared, and the c is the longest side on our right triangle. 5 squared, 5 times 5 is 25, 10 times 10 is 100, and then if you add those together is 125. So the radius would be the square root of 125, and then the area of a circle is pi r squared. So pi times the square root of 125 squared. And then basically what happens is the square root and the square cancel out. So that would be like pi times 125, or 125 pi square units is kind of the format that they listed their answers in. And the thing about it is, with it being multiple choice, once you get to that point where you find the square root of 125 and you can see that you're going to just be squaring that, you'd be looking for that 125 in your answer then. The next thing is classification of triangles. And again, they're probably not just going to give us a triangle and say, is this scalene, isosceles, equilateral? They're probably going to give us something a little more involved. They're kind of doing a lot of things with graphing points and things, so we'll just do a problem similar to the practice question they have. So if we just consider this problem, here are 3 points, and those are the vertices of blank. The options would be like, a right triangle, isosceles triangle, equilateral triangle, scalene triangle, and we can do again, we can just quickly graph these, would be one way of doing this. Okay, and I just made these up, so this is not really looking that great, but okay. So probably it's just going to be a scalene triangle. What you could do is you could construct right triangles and see if any of them are the same or not. So like up here, this would just be a 1 by 1 triangle. This one, we'd have to go up. Let's see, we're at -5 going up to 4. So -5 to 0 would be 5. 0 to 4 is 4, so that's a total of 9. So we've got a 9 by 9 by 2 rectangle there. And then this one, we've got, we're going from -1 to 4. So that's a difference of 5. And we're going from -5. This should be to here, sorry. -5 to 4. So this part's 5, that's 4, that's 9. So we got a 5 by 9. The other one was a 9 by 2. So basically, if you would, it's possible they could look different, but the triangles could look different. But if you add these together, they should be the same if they're the same length, because this is like our a squared plus b squared equals c squared, and that would be finding this value, the distance of the side of our triangle. So since all those are different, this would be a scalene triangle. Okay, so something like that. Like I said, just kind of graph it out. Sometimes you might be able to kind of eyeball it and see just by looking what it is, but if you're not sure, this would be a way of figuring out for sure what kind of triangle it is.